Hello, and welcome to Math 103, Calc 1. I'm your professor, Danny Klein, and what I'm going to be going over today is an introduction to the concept of the limit. A limit is essentially a concept related to that of a function, and a function is something which you should have all already seen in a pre-calc class, but limit is a concept related to that, which is sort of what allows all of calculus past that point to work. Essentially, all of our definitions and concepts rely on the concept of the limit. And so that's what we're going to be looking at today. And to start with, we're going to look at two functions, and they may not look it, but these two functions that we've got right here, function 1 and function 2, let me see if I can get that a little bit better here. Function 1 and function 2. These two functions are going to be the two functions we're going to look at. They're related to one another very closely, but they're different in a way that'll let us get at what we mean by a limit. So that's what we're going to look at today. Okay, so let's start off by thinking about what would happen if we graphed these functions. So as you'll recall from pre-calc, we have essentially three different ways that we can look at a function. Three main different ways. One is as a formula, which we've got here. I've just highlighted those in yellow. Another is as a graph, which we'll put below the formula on those x and y axes. And the third is as a table of values, which you can see right below those graph axes that we've got set up. So that's where we're going to go, where we're going to start today. So let's start off. Occasionally I'll be zooming around on this map, so on this PDF, so that you can see specific things and so that I can write clearly enough for you to be able to read it. So be aware of that. So what we're going to start with is looking at how would we plot function 1. So let's zoom in here to our table for function 1. You'll notice I've got another table below it. We'll use that a little bit later. So first of all, let's look at this function 1. You'll notice our function is x plus 1. So y equals x plus 1. I've got a table here of x values. We're going to plug those in. And so what I'm going to do first of all is I'm going to zoom in here so that we can see them up close. And I'm going to give you all a chance to pause this video and fill those in yourself. Remember, the function itself is x plus 1, and we have these x values that we're filling in. So go ahead and pause the video if you'd like. Okay, now if you've paused this and filled those in, most of what I do from here on out will be stuff that you've already done, but let's go ahead and take a look. So here, our first x value is -2. If we plug that in for x, we should get -2 plus 1, which if we add that up, we should get -1. Okay, fairly straightforward. We can keep doing this. If we take -1 plus 1, we should get -1 plus 1 is 0. We can keep doing this. I'm going to skip the actual plugging in an addition from here on down because it's just going to take up room and time, and you should be able to follow along. If I plug in 0, I get 0 plus 1, which is 1. 1 plus 1 is 2. 2 plus 1 is 3. Let's scoot down a little bit here. 3 plus 1 is 4. And 4 plus 1 is 5. And these are our function values for that function that we're given. Okay. And this gives us our points that we can plot to get a better picture of what that graph looks like. So what the function looks like as a graph. So let's go ahead and scoot in here again, and we will write out what these points are first. So let me put this in blue because I think that's how I'll do it for the graph. So here, my x value is -2, my y value is -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5. So these are the points that we're going to get when we plot this graph out. Now, again, sometimes I'm zooming out and zooming in. Hopefully it's not too jarring when I do that. So let's actually plot these points on the axes that we've got up above, and let's take a look at what our graph looks like. So our first point is -2, 1. So let me make the points in blue, and I'll put the line in red. So -2, we go backwards on the x-axis 2, -1 for y, we go down 1 for y. So I should have, about that point right there should be -2, -1. The next point, -1, 0, back 1 on the axis. The next one is 0, 1, which would be this point right here. The next one is 1, 2, which will be that point right there. Oops, let me try and get that solid there. Those open circles will mean something a little bit different in a minute. Then we have the rest of these points, 2, 3, 3, 4, and 4, 5. Okay, so this is essentially something that you would have dealt with in pre-calc, plotting these functions. It wouldn't be anything new for you, or it shouldn't be. And if you notice, the kind of function we're getting here is a straight line, which is a fairly simple function. So I'm going to try and draw that in as straight as I can. We get a function that looks like this. You can still see most of those blue points that I started out with there. Okay, so hopefully that makes sense. If at any point things on this video don't make sense, you can feel free to ask me questions in the text chat that I'm going to have set up for all of you, or you can feel free to ask me questions on email or video chat if we get that set up. Sometimes the video chat has a little bit of issues from day to day, so just keep that in mind. Okay, so this is our first function, a simple function, and we're not really getting anything new about limits there. We'll get the idea from how this next function relates to it. So the next function is a little bit more complicated than the first. Although, if you're careful about it, you might see already how they're related. The second function is x squared minus 1 over x plus 1. So what we're going to do is start out the same way that we did before. We're going to have this table. Let me see. I'm going to try and zoom in so I get exactly what I want here. Okay, so we have this table where I have x, and my g of x is x squared minus 1 over x plus 1. So what I'd like for you all to do, again, is pause the video, try to figure out these values. These ones will be a little bit more complicated, at least at first. So go ahead and plug these values in, figure them out, and see what you get. Okay, if you're back, let's take a look at what we get here. So I think I might need to zoom in a little bit further here. Our first value is -2. So if I take that and I square it, I get -2 squared minus 1 over -2 minus 1. Now, of course, this is a little bit complicated. -2 minus 1, -2 squared is 4. 4 minus 1 is 3. So 3 over -3 here is what we get if we work this out. And if we remember how our fraction rules work, this should give us a -1 value there. Okay, and let me zoom back out again. If you'll notice, this is the exact same value we had on the other function. Okay, so let's do the next one, and I'll try and do these a little bit faster, but I do want to put the form of each out so that we can see exactly what's going on. Okay, so the next one I'm plugging in -1. So I get -1 squared minus 1 over -1 minus 1. Oops. 1. And if we work that one out, we should see on top we get -1 squared is 0, minus 1 is -1, or -1 squared is 1, sorry, minus 1 is 0 over -2, and 0 over -2 gives us 0 for this value. Again, the same y value we got before. We can keep doing this. I'll go through a little bit less explanation as I go down through here. So 0 squared minus 1 over 0 minus 1 gives us -1 over -1, which works out to be 1. The next one, we get something a little bit more interesting. So here, I get 1 squared minus 1 over 1 minus 1. Well, this one is a little bit different than the others. You'll notice all the ones we've done so far, the final values have worked out to be exactly the same as what we had in our first function. -1, 0, and 1. Here, though, if we look at our top, we get 1 minus 1, which is 0, over 1 minus 1, which is also 0. Now, 0 over 0, the one thing we all remember from most of our math up to this point, at least one of the things, should be what we're not allowed to do, which is not allowed to divide by 0. So let's take a look here. We will make this, I'll make this match, and we'll write this out. Undefined. So this value is undefined right now. So we don't have an actual value for this one. So every point that we've got up to this point, -2, 1, -1, 0, 0, 1, these are all the same as the ones we had before. So I can even write those out. We'll get to the other ones here in a little bit. So I would get -2, -1. I would get -1, 0. And then I would get 0, 1. Those are all the same as what I had on my first graph. However, this next one, my y value is undefined, so I don't have a point there. We'll continue on, and I'll try and make these last few quicker. We're going to get 2 squared minus 1 over 2 minus 1. That's 3 over 1, or 3. And again, sorry for moving these things. Hopefully you all are able to follow what I'm doing. Then I get 3 squared minus 1 over 3 minus 1. 3 squared is 9, so minus 1 is 8. 3 minus 1 is 2. This gives us a 4. And finally, we get 4 squared minus 1. That's 16 minus 1, or 15, over 4 minus 1, which is 3. So 15 over 3, which is 5. And just to finish this off, I'm going to put my points in here again in blue. We'll do this. This was 2, 3. This is 3, 4, and the last one is 4, 5. And at this point, if we look back at our original function and the points we had, we'll notice everywhere we have a point, so each of the things that isn't undefined, we have the same point that we had originally. But we do have that one spot that's missing, that undefined value. So let's go ahead and put those in here like we did before. So our first one was -2, -1, which is right about there. Sorry. Our next one is -1, 0, which is right about there. Then 0, 1, which is right about there. And then we have our undefined value. And how we measure this is we will write it out with, I'm going to have to zoom in for this one, sorry. We will write it out with an open circle. Okay. Now, we continue from there. We've got a point here, and a point here, and a point here. So all of them are the same except for that open circle, and that means the function doesn't have a value at all at that point. So, continuing on, let's actually sketch this in like we did before. We get a graph that, again, zooming out, looks almost exactly the same, except there's one missing spot in it. Sometimes you'll hear that called a hole in the graph, and so that's exactly the difference of what we have here. So these graphs, let me zoom in and over here and type something up for us. Let's do it right there, and let's make this black this time. These graphs are the same, except, sorry, at x equals 1, where the second has no function value. Okay, so that is what we notice about these two graphs. They're the same except at that one point where the second doesn't have a function value. Okay, so this is sort of getting at the idea of the limit. So what we want to talk about in terms of the limit, let me zoom down to the bottom, and I will put up what we use as, I won't put up what we use as a definition of the limit here because I don't want us to get too in the weeds on that. But this is sort of the word's definition of what you'll see in your book as the actual definition of a limit. So, definition of a limit. What this means is we say a function has a specific limit value. Didn't mean to go off the side there. Value. If we can make the function value as close as we want to the limit by making the x value closer to the value we are approaching. That's the words version of that definition that you see in the chapter. In other words, we say the limit of the function as x approaches a of L equals L if for any epsilon greater than 0. That epsilon greater than 0 is essentially how we're describing this closeness here. So let me write this out in words here so that we can see it without the oops, it's not the one I want. Blue. Okay. So let's see. How we would write this out is we would write limit as x approaches a of f of x equals L. So, in other words, in terms of what we've written here, the limit value that I'm talking about right here, this is what we mean by L. Let me try and get that arrow a little bit better there. So this is our L value. That's the specific limit. And the value that we're approaching here, this is that A value. In other words, what x is getting close to. So you can look at this down here, this written out version. This x going to a, that is what x is approaching. F of x is your function that you're allowing to change in response to how x changes. And L is the limit. That's what that function value gets close to. So as x goes to a, the function goes to L. That's the idea here. Okay. So the idea of that, you might almost be able to say what the limit is in both of these cases without going any further. But let's actually use this idea to look for two things here. Let's look for and let me put these in here in blue. Let's look for two things. Limit as x goes to 1 of f of x. That's the first thing I want us to look for. And the second thing I want us to look for is the limit also as x goes to 1, but this time of g of x. Now, looking at this, one of these, just given the functions that we have, is going to be considerably easier. That first one, as x goes to 1, we know what f of x is getting close to because we know exactly what the function value is there. We know that f of x equals 1, and we know that these points are all connected in that straight line form. The second one's a little bit tougher because what g of 1 actually is undefined. So what we might do, and what we usually see about how we do these things, is we will plug in again. Let me write the function form out here again. This is x plus 1. We will plug in x values, except now instead of picking just any old values like we did before, we're going to pick ones around the place where we want our limit. So if our limit is 1, we want values close to that. So one way to do that is to pick values that instead of being 1 apart, we just get closer and closer in. So I'm doing 0.5, 0.9, and on the other side 1.5 and 1.1. So you can see that those are getting closer to 1. If you had a bigger chart, you can actually do this further in. So you could pick right here And right here, instead of just having a 1.1 and 0.9, we might have a 0.99 here, and down here a 1.01, so even closer to the 1 value. And you can keep doing that closer and closer. Now this function is easy since it's just adding 1. We would get 1.5, 1.9, 2, 2.1, and 2.5. And if we picked values as we saw over here, 0.99 and 1.01, we could find those values as well. And if we look at this, as we squeeze our x value in toward 1, so as we get close in towards 1 here, our y values close in on this 2 value. And that's what we see for our limit here. So up here, what we would then say is this limit equals, now I'll use a different color, 2. Now, the g of x one we could think will be actually a little bit tougher, but in the end it's not going to be that much tougher. So I'm going to do the same values I did before, so 0.5, 0.9, 1, 1.1, 1.5, and like I said before, I could put other values in here. I could make this chart bigger. I could have a 0.99 there and a 1.01 here, and I could even do more. I could have 0.999 and 1.001. Now here, if you remember, our formula for g was x squared minus 1 over x minus 1. Now, there are certain things we could do to this. I'm not going to go over them. There are certain algebra things we could do to simplify this. I'm not going to worry so much about that right now, but let's go ahead and find out what these values work out to be. So I'm going to let you pause this, and in this case, it's probably worth punching these into a calculator. You do have to be a little bit careful that you have your calculator, what you plug in, set up right so that you're doing order of operations correctly, but we'll go ahead and let you do that. So go ahead and take a little pause here to do that, and then when you restart the video, I'll fill these in. Okay, so let's actually zoom in here, and if you'll recall, we've got 0.5 there, and I'm squaring 0.5, subtracting 1, and dividing it by 0.5 minus 1. So let's actually do this out here. So 0.5 squared minus 1 over 0.5 minus 1. I'm only going to do this first one out the whole way. 0.5 squared is 0.25 minus 1 gives us negative 0.75 over 0.5 minus 1 is negative 0.5, and that can be not the easiest thing in the world to do in your head. One way to do it is you remember the top is 3/4 and the bottom is 1/2, and just divide fractions, and the negatives cancel because you don't have to worry about that. But in any event, you get what we find to be 1.5 here. We'll zoom back out. I'll fill in the others. I'm not going to go through the process of simplifying in the other cases, but here we would get 1.9, 2.1, and 2.5. Now what happens at 1? Well, the exact same thing we saw happen at 1 before, which is that this value is, put it all in caps this time so we can freak out about it a little bit, undefined, right? And how many exclamation points should we put? Like 4, just to really blow our minds. Okay, so there we go. So the one value is still the same that we had before, but we can see no matter how close we're getting in, we can get as close to this value of 2 that we're looking at. So here I got 0.1 away. If we'll look right here, here I got 0.1 away from 2. Here I got 0.1 away from 2. If I had plugged in these 0.99 and 1.01, I would have gotten 0.01 away from that. And if I pick values as close as I want to 1 over here on the left, I can get values as close as I want to 2 on the right. I can't get values exactly equal to 2, but I can get as close as I like otherwise. And what that tells us here is the same thing for g that it told us for f. The limit of g as x approaches 1 is also 2. So that's the idea of what we mean by the limit of a function having a specific value. So one thing we need to notice here, and I'll put this in, is we will need to notice that for limits, for function limits, it doesn't matter. I'll put that in caps. Doesn't matter what the actual function value is at a specific point. For your x value, just what it's getting close to. And that is the idea of what we mean by limits. So, as you can see here, I've edited out the PDF. I will be putting this this video link on your Moodle page as well as the final version of the PDF, and you can use this to go over and work this out yourself to figure out what we mean by the idea of a limit. So that's our first video. Hopefully it went well for everybody. Again, if you have questions, you can email me or contact me on the chat, which I will be setting up shortly. Please let me know if you have any issues or questions. Thank you very much, and I'll look forward to seeing you again at the next video.